Hello, this is Noah Housley with problems and just explanations on Math 302. This is in 2.3, working on spans. I'm going to do just an example problem. Show that R2 is equal to the span 2 over -1, 1 to 3. So first, I wanted to define a span, commonly confused with spam. So span it just means that there's vectors, so these are vectors, just that there's vectors in a linear combination. And so how you define that vectors in a linear combination is meaning so that if I had one vector, so if I had vector A plus vector B is equal to some C vector. If it's a linear combination, that means that there's some x and some y that I can multiply by these two that's going to equal this vector here. And so what this is asking is show that these two are in a span, or R2, specifically the span of R2 equals the span of these two. So how we kind of are going to approach this is we want to solve it like we would a normal linear combination, which means we put in this equation of C1 times that vector plus C2 times that vector is equal to this matrix and or vector, if you could call it. So then from this point, you can put it in an augmented matrix. Why? Because it's like a normal systems of equations. Technically, you have two equations here that that one equals A and one equals B, and these coefficients are just being multiplied into these matrices. And so technically, you have these two equations and two unknowns to solve for. You can put it into an augmented matrix and then put it into reduced or echelon form. And after you do all that work, be sure to keep A and B and keep track of them. You get out that A is equal to 3A minus B over 7, and B equals to A plus 2B over 7. So the fact that we got a unique answer proves that we can plug it back into here, and this shows that it is a linear combination. Thus, since it is in a linear combination, they are all in the same span. So we got that any arbitrary numbers here, A and B, within this two-dimensional span, or I shouldn't say two-dimensional span, within R2 are equal to this, are in the linear combination of this span right here. Okay, all right, that was video. I had also an approach over here, just explaining the augmented matrix, and then to put into a reduced row echelon form. Sometimes when solving these, you don't need to put in reduced row echelon form, and that's usually when you can see early on that one of the answers is going to be a free variable, and you're not going to get a unique unique solution, and so it'd probably be into not a span, it would be a dependent variable. Okay, hopefully this helps. This helps my own study mainly. Thanks for watching.